Yo, yo, yo. What's up? What's up? Welcome back. Today we are working on my stream intro screen. So for those of you who were here on Twitch a second ago, what we have right now is before stream starts, we show this like maze in the corner and we show it full screen and we say like stream starting at some time. And the reason to do that is because one, it lets people who are viewing on Twitch, it gives them some time to like get in when they find the stream starts and not miss the intro. And two, it lets us run an ad before stream starts, which disables pre-rolls. So on Twitch, when people click on streams, if you haven't run 3 minutes of ads within the last hour, new viewers come in and instead of getting straight into your stream, they get these like pre-roll ads. And when I'm browsing Twitch, sometimes I'll like click on a couple streams and I'll get hit by pre-rolls like 2 times in a row, and I just like Alt F4. I'm like, fuck this, it's not worth it. So by adding like this like stream starting screen, we get like to avoid that pre-roll problem, and there's like some other benefits there too. And so what I was thinking was, this is like a coding stream, so it'd be kind of fun to have some sort of like terminal looking thing that says like stream starting in, and then like maybe it says like it looks like somebody's typing in how long is left, so like it will say like 10:00 and then like backspace to 9:09:59 09:58. And it might be kind of cool to like render that. I don't know, I wanted to try it and see what that looks like. It might look like shit. And then you could have like, you could have like a little cursor blinking here, and maybe you could like make it look like, put on some like extra post-processing effects to make it look like a CRT or something with those like little like magnet like shitty interactions and like banding or whatever. I don't know. We'll see what we want to end up making, but the key here is that we want to draw some stuff on the screen. We know that there's going to be some form of text, and we know that that's gonna like I'm programmatically going to want to like generate this by putting in a message and having like it update over time with some form of like with some form of automated logic. And so me being a programmer thinks like, well, how do I like draw something to a screen with some frequency? And game engines might be a good pick for that, but in reality, we're not doing anything that's really like, a game engine seems like too much, right, for what we're doing. So it seems reasonable to try spinning up a quick little OpenGL app and rendering the text ourselves. And so it turns out that's not like extremely trivial, but we started on it yesterday. And where we got to was, if I run my thing, sorry, just reduce the font size a little bit. We see a big F on screen. Now this F looks totally fucked, right? It's like completely square. It's low resolution, whatever. But it is drawing a character, and we can update which character we want to show. So here we have like draw an F, and I'll like draw C. We get that instead. Pretty sick. And so the next thing to do is figure out like, well, how do we render this as like a smaller thing, and how do we like lay out a string of text instead of just the one character? And so what we've got so far is we're using OpenGL to essentially render an image. So you can imagine our OpenGL world as like being some form of 3D world. But in our 3D world, all we're doing is we're taking like a plane, like a quad, and maybe I should also, it's probably better if I say triangulate here. So we're essentially drawing this, where we take 2 triangles that make up a square, and we're filling the screen with that square, and we're drawing our character on top. We're using freetype to take a letter and turn it into a bitmap that they call like a glyph. And then we just take that glyph and we store it on our square. And so what we want to do now is we want to adjust where we're rendering that. So there's kind of like 2 approaches that we could take to this. One is that we could like shrink this plane and scale it down, right? Like we could make like, we could say like, well, the character is supposed to be this, and so we'll put it here. I guess kind of both both mechanisms do that, but it's kind of like how that's done, I guess, is like the two options I'm thinking of right now. So what I'm thinking is you could either move the definition of like where each of these vertices on the plane are. So you could like take each of these and like move them up like this. Like I say, like now render the character here. And like we have like this like definition of a quad, and we can move around. Or we could say your quad is always going to be like -1 to 1, right? You can see like the X and Y axes here kind of make it look like it's how do I show see-through? It's like -1, -1, or sorry, 1, 1, -1, -1, right? We could say, okay, now take that square and scale it down and shift it, which are semantically, like, those sound very similar when I say them out loud, but semantically they're kind of different. And so here, we'll see if we can like kind of show what I want to show here. So in our like vertex shader, there's like two types of inputs. Okay, so first of all, what the fuck is a vertex shader? Vertex shaders are essentially ways for us to manipulate a single point from this like quad, right? We pass in like this point here. Our vertex shader could say like, oh, you passed in this point, but I know that like I want to move it over here. So the vertex shader could move stuff around. What we're essentially doing is we're taking in like a 2D vertex and just converting it into a 4-dimensional one, and we're not touching it at all. And so that's one type of thing you can do, is like you can basically, you run this like these shaders, the vertex shader for each vertex. So this gets run 4 times, one for each of these. And so you could either say, well, we'll change which 4 vertices we're passing in here, or we could pass in this thing called a uniform, and we could call this like scale X. I think it's like uniform float scale X, something like that. And we could say like, well, if I pass in 0.5 before running this, we're essentially going to shrink all of these by 0.5. And so that's like the two approaches. There's pros and cons to each of them, I think. I think one of them might theoretically be faster, because when you run OpenGL code, it's I think it's supposed to be faster if you batch all of your calls into one thing at a time. But we're probably rendering so little that it doesn't matter. So we'll just do whatever makes it easiest for us to implement. After like we go through a vertex shader, what happens is that we run this fragment shader that basically says for every pixel within this like thing that you drew, I'm going to interpolate between these like vertices. So like if I'm drawing this triangle, it's going to basically say like for each pixel I'm going to go like bump, 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 iterate over, and like if you're in the center here, you're going to get a position that's like it's not this one, it's not this one, it's not this one, it's like in between. So they're going to interpolate the vertices for us and call this guy for each pixel. And so what we do there is we pass in as like a uniform. We say we're going to draw the character C, and so we like put that character's like picture in GPU memory, and then we like sample that picture based off where in the quad we are. So that's where we're at. That's where we're at. And the thing that we want to do is we want to start implementing scaling. So let's start on that. So in our Rust code, yesterday we kind of had everything in main. I did make a few changes, just like refactoring to make things kind of cleaner, put them in like logical spots and stuff. So now we have this like thing called like an image renderer, and essentially this guy has like one API that's render a texture, which is like that thing we were sampling. So we say like, okay, we've generated a picture for this character, and now render it, please. And so all we're going to want to do here is we're going to have to put in like X as a X position, Y position, and then probably a width and a height. And that should be enough to update this guy. I was referencing this like, oh my God, I don't have a window open for this. Hold on. I was referencing this learn OpenGL text rendering page. Bonk. And let's see. Oh my God, add. So here's what they were doing, is they iterate over each character when they render a string. And they're taking the approach of updating the actual vertices for for the quad that we're rendering, instead of updating like a uniform for it. I think that's fine. That kind of makes it, I kind of like that approach a little bit better, specifically because it means that our vertex shader doesn't have to get smart, right? Our vertex shader at this point is like dumb as fucking bricks. It does like, this is like the lowest amount of work that you could possibly do in a vertex shader. And so if we start adding in like scaling here, it does have to do like a little more. And I do kind of like both of those. It doesn't really matter if that's done on GPU or CPU, because it's such a small amount of data. If there was like a lot of vertices, if we were rendering like if our thing was like 1 million vertices, right? Then it might make sense to do the scaling of each vertex on the GPU so that it can run in parallel. But in this case, it doesn't fucking matter, right? We're only updating for, it doesn't matter. So I think we'll just do it that way, the same way that they did it in the Learn OpenGL code. And so what they did is they called this thing that says just update. So that we have a quad already. When we boot up, we are generating one that fills the screen, -1 to 1 1 essentially. And so we can just update that existing guy. And I think that we can just say they have this API buffer sub data, which I assume stands for substitute the data in a buffer. GL buffer sub data. Let's pull open some docs for that guy. So this guy updates a subset of a buffer's object data store. Okay, so we're gonna update the subset, which is the whole set. But I guess that's how you do it. And then you say, here is the target. So the target is an array buffer. This is vertex attributes, that's what we're doing. So we'll say, before we do anything, we're gonna say GL buffer sub data. In the Rust bindings that we're using to OpenGL, they expect the data to come in as a U8 slice, but in our case, our vertices are actually stored as floats. So we have to like cast between them. So let's actually just like quickly pull out our function to do that. We'll say, onsave function. We'll call this like F32 to U8 slice, I guess we'll call it. And we'll say our input slice is a list of floats, and our output slice will be a list of U8s. And I think we can just do this. So we take our input, we cast him to a pointer, and then we cast that pointer to a U8 pointer and then reinterpret him. You have to be careful generally with these like pointer typecasts. It's riddled with undefined behavior. But if I remember correctly, everything is valid to cast to a bunch of U8s, specifically because like memcopy and stuff do that. So that's part of the standard, and otherwise, I think that this is fine. So then we'll take this guy and we'll say F32 to U8 slice, where this guy was the vertex data before. And I think we just have to I just want to make sure that that still does what I think it's supposed to do. So we'll just quickly stub out these changes we were making and cargo run to make sure that we still see a character. He doesn't like that I didn't return that value, so whoops. Okay, so that's still running. Bing, bang, boom. Cool, cool. And so now, wherever we were, here, we can update our data with vertices based off x, y, width, and height. So I guess first we're going to have to make those values. So we're going to say we have to be careful about the order of vertices. So our vertices are going to be in the order of whatever makes two triangles draw back to back. Like, so in this scenario, we have 4 vertices, and the way it's going to draw them is it's going to draw like the vertices 0, 1, 2 as one triangle, and then 1, 2, 3 as another triangle. So we actually have to zigzag the vertices to make sure that like the 2 triangles that we draw will create a quad. So we have to draw 0, 1, 2, 3, so that you go 0, 1, 2 to make this triangle, and 1, 2, 3 to make this triangle. Yeah, so we're gonna say let top left is equal to the x position. Well, okay, so we could pick several coordinate systems for this, so we have to be careful here. We should say that our rectangle, our x and y, do we want them to be the center or the top? if we make them the top left, that's easier for us because we don't have to do any math here. And I think that might work out better in freetype. So like the width, like the characters that freetype give us might expect the X and Y position to be in a certain position. So for now, we're just going to call it top left, and we'll adjust later if we need to. So we'll say let verts is a F32 slice. Oopsies, is equal to slice whose coordinates start at X, Y. So we're just going to say X, Y is going to be the top left vertex. Then we're going to do, we have to be careful here. It doesn't really matter, but let's say that we start in the top left, then our triangle is going to look like this. And so we would do top right next. Yeah. So let's do top right. So we do X plus width, Y. Then we do bottom left, which would be X, Y plus height. And then the bottom right is X plus W, Y plus H. So those are the four corners. And then we just have to update those. So we say GL buffer sub data U8 slice. The target is a glow array buffer. The offset, we're going to update the whole slice, so 0. And the source data, we're going to update it with these verts. So we're going to say F32 to U8 slice of verts. Okay. So first, we're just going to do this with -1, -1, 2.0, 2.0, because that should be the same thing as what we had before, and we should still see these guys render the full screen, essentially, which we do. And if we, say we, half these, we should see him only be in the corner. Okay, so that's pretty good. Except it doesn't look like the texturing has, kind of matched that. We've kind of cut a corner out, but we haven't shrunk the whole texture. So let's look at our fragment shader and double check that we're doing the right thing. So our normalized vert. Oh, is this in screen space? So we might actually have to, in our vertex shader, somewhere we might need to specify the width and height. Let me think. Because the vertex positions that we're getting out are just raw 0 to 1, it looks like. And so here we normalize those 0 to 1, but then we also have to scale them down. So I guess we have to put in the width and height here as well. I guess. Is that reasonable, or is there another way? I think what I've seen people do before is you can pack the texture coordinates in alongside these guys. So here we'll just pack in texture coordinates like this. So we'll say that this is the top left corner, this is the top right corner. So we can say 0.0 F32, 0.032, 1.0 32. This is going to be the bottom left corner or the top left corner. I'm not really sure. I guess we'll find out. So this is 1.0 F32, and 0x 1y, which means that we got this backwards. It should be 1x 0y, and this could be 1 F32, 1 F32. So this is the bottom right corner. Yeah. And so then we just need to update our expectation of the vertex shader. And he is not going to be a vec2 anymore. He's going to take in a vec4. And he's going to output the texture coordinate. So here we can say that the output thing is invert dot xy zw. So we're going to take the last two things and we're going to put those into we're going to feed those to the texture, to the fragment shader, which are the texture coordinates. And then we're going to use vert.xy, what do I call these? Sorry, my brain's melting. the vertex coordinates, we're going to feed those in here. And then we just have to update somewhere. We have to be careful about where we define this guy. We say, hey, the data we're giving you right now, you should expect it to be 2 bytes long. And we're just going to say, nope, you should expect it to be 4 instead. Is it supposed to be invert XY? Yep. Good catch. Good catch. Okay. So let's see. That doesn't look like it's doing what we expected. So we also, let's just double check this API to vertex attrib pointer. Oh, we probably have to fix this definition as well. So we'll just do the same thing. We'll just copy these, I guess. So 0, 0, 1, 0. Ah, fuck. Fine, we'll use our heads. So this is 0, 0, F32, 1, F32. This is 1, F32, 0, F32, and 1, 1. Okay. I don't know if I fucked something up heavily, so we're just going to go back to our main, and we're going to say, please draw the whole character again, just so I can look at it. And it does look like we fucked that up, probably because in our fragment shader, we're still doing this scaling, which we don't want to do at all, so we can just use the input vert here as our sampler. Okay, so we've got the C there. And if we half the width and height now, there we go. Cool. So that's pretty sick. And now let's try rendering it in the middle of the screen. So I'll offset it to like, what is it? Negative 0.5, 0.5, I guess. Because these are negative 1 to 1. Yeah, okay. So that looks like it's working right. We will also notice that the edges of this are like kind of fucked up. I'm just ignoring that for now and choosing to deal with it later. Okay. The last thing I want to change here is packing these guys in as like one thing doesn't really make sense, right? These are like not one vec4. These should actually be 2 vec2s. So we should be taking in the vert chord and the texture chord and outputting a texture chord. So we'll say that the output is, we'll just call this out chord, and we'll say that the out coordinate is the texture coordinate. And the position is based off the vert coordinate. And then we just have to be in when we upload the data, or we set up our like vertex buffers. Here we're saying like, we'll actually set 2 sets of 2. So let me double check the API here. But if I remember correctly, we've like packed this buffer with like parameters, and now we're trying to like we're telling the system how to interpret those parameters. So I have to look up this vertex attrib pointer call, gl vertex attrib pointer, and he takes in an index, which is the index of the generic attribute to be modified. So the first one is going to be the vertex position, and the second thing that we're going to look at is the texture coordinate. The type, or the size, is how many components per vertex attribute. So we have 2 here. Type specifies what it is. So here we have floats again. Great. Normalize specifies whether they should be normalized. I guess for texture coordinates, technically they should be, but I think it's okay to put them. Oh, yeah, fine. Fine, we'll say they're normalized. The stride specifies the byte offset between generic attributes. So stride is 0, they will be tightly packed. So here we have to up them both. The stride between them is going to be 4, because there's 4 things per chunk, right? 1, 2, 3, 4. Even though they're only 2 long. And then the offset, we have to say how far into these do we start. So in this case, we're 2 in to get to the vertex, the texture coordinates. And I think if I did all that right, it should still work, and it clearly doesn't. I clearly fucked something up. So let's try to figure that out. So these guys, oh, I put their locations as the same thing, which is a big mistake. Which doesn't seem like it fixed anything. Out chord is texture chord. GL position is vertex chord. What happens if I go back to how it was? Okay, hold on. Hold on, I've clearly fucked something up. Clearly fucked something up. So we'll disable this texture chord stuff. We're going to just say the output coordinate is always 0, 0 for now. I just want to prove to myself that we're getting like a black or white square somewhere. So this should be vec2. And that's still not good. So here, let's double check this guy. So he should have two long. He should be, yeah, have 2 bytes or 2 floats, but they should be 4 apart, 0 offset. And that's not drawing what I expected. So I wonder if we can like start like corrupting this just to see. Just to get a feel. So here we generate our square buffer. And he should have -1, -1, 1, blah, blah, blah. And then here we update him. And so can we try like... So say, let's just for the sake of things, duplicate the coordinates over. Instead of trying to do normalized coordinates here, we're going to say x, y, or sorry, the texture coordinates. We're just going to duplicate the vertex coordinates again, just to see if we've messed something else there. Okay, cargo run. Now we're seeing nothing. It's possible that our draw arrays call here is doing something wrong, so let's double check that. You might not like it when they're split up. First is the started index in the enabled arrays, 0. Count is the number of indices to be rendered. So I think that should be 4. If I write 8, what happens? Can't imagine that should be 8. So 8, we're seeing like a weird triangle. It's possible that it's not, it's interpreting these as like packed without the texture coordinates, right? Like maybe it's expecting this. Okay, that's something. What happens if I draw 4 of these again? I'm seeing a triangle without the top half, so that's interesting. I wonder if I have to re-update my vertex bindings. These guys aren't doing that. Oh, but they are rebinding the buffer after they update. Which is kind of interesting. So maybe we should be doing that. So let's bind buffer some self.vbo. I assume that this isn't relevant, but it's worth trying. And this is glow array buffer is what we're trying to target. I imagine this just doesn't change anything, but it's worth looking at. Yeah, still just a triangle. Interesting. So I wonder what I fucked up. Let's just go back to the case where these are packed 2 by 2. Okay, we're getting something real fucked up. Why is anything in the center? We should have nothing at 0, 0. Does freetype have good Rust bindings? I don't really know, because I've never used freetype outside of Rust. In terms of just like getting the bitmap, it seems like it's working fine. But yeah, I'm not sure. Not sure. Okay, so I feel like now we should be kind of like in the same spot that we were always in. Let me just, we're going to go as far back as we can here. Let's just double check our vertex array. So at this point, everything should be vec2s. And so here, when we generate our square buffer, we generate a list of 4 vertices that are two floats long. When we bind them, we say that they're... Oh, this isn't bytes. The stride isn't bytes. And maybe the size isn't bytes. Let's double check this. That's probably where I fucked up. Oh my god, which of these like 50 windows is it? So the size is the number of components, but the stride is probably in bytes. So let's try that. So we'll say that this is 2 times 4 for the size of a float 32. And cargo run and see what happens. There we go. That looks better now. So that was probably the problem the whole time. So let's undo a bunch here to get back to where we had these guys packed together. And these guys should be 4 times 4, both of these. And we still see a black square. Great. And now we can go back into our vertex shader and re-enable the passing of texture coordinates. Which are not looking good. Why not? Was that not there? So we have offset by, oh, maybe this also has to be offset by 2 times 4, maybe? Maybe that's also in bytes? No? Not sure. So here we're saying our out chord is a texture chord, and in our fragment shader, are we correctly using that? Yeah, we're using that vertex. Vertex attribute pointer. So he takes the index of the generic vertex attribute to be modified, so that should be 1. The size should still be 2. The type should still be float. Great. Normalized, we set to true. Maybe we'll set this to false just in case. The stride is the same. The offset should be 2 by 4. Interesting. Let's just double check here that if I do something like set this to white, we should see a white square. Good. And let's also double check that if we like wiggle this guy around in main, we pass in like, let's try to draw in the corner. Or sorry, in the center. Yeah, in the corner. So that the vertex positions are definitely getting updated correctly, but it's just the texture coordinates that aren't for some reason. And so that I don't really understand. Let's just double check that we have bound this, which we must have, but let's just double check. So this is some self VBO for the vertex buffer object. Yeah, nothing changed there, which I didn't really expect them to. I wonder if after we bind them, we have to reset these attributes. So let's just kind of copy paste this here and just see what happens. Nope, nothing. That's really odd. I guess we should also double check that the texture is, in fact, still there. So let's go back to forwarding the vert chord here, just to make sure that we get like something. So it's still all black, which is kind of odd. I would expect to see something here. Sorry, vert chord plus 1.0 divided by 2 to get back into normalized. Yeah, that's weird. So we're just getting no... We're just getting no texture, which is kind of odd. I feel like we didn't change much. Maybe the uniform isn't set? Yeah, that's what I thought too, but it seems like it should be. If I comment this out and disable the like... Let's just completely disable texture stuff and try to get back into the state where it was working. Because there's something we clearly don't understand here. Clearly something that I don't get. So let's just go back to drawing the full square. Sorry, for the side, for the full screen. Great, black screen. And so our fragment shader, let's go back to just passing out the vertex coordinate that we passed in directly in the fragment shader. We are sampling this guy. Okay, so let's, instead of sampling, let's just put the vertex color directly, just to make sure that, to see if that's working, because that should give us a clue. We see a fully blue thing here or something. Our vertex coordinates aren't getting passed the way we think they are. Which is odd. Definitely odd. Do things like render doc work in Rust? It should, right? What the fuck is render doc? Graphics debugger. Oh, that sounds extremely nice. I've never used this, but invaluable graphics debugging tool. Yeah, sure sounds like it, because what I'm doing is fucking stupid. I'm gonna write this down to try it later off stream, because I don't think it's good for me to like just randomly try shit on stream, because it's just a waste of time, I think. But I will take a look at that, because that seems pretty interesting and useful. Okay, so is it possible that, so our vertex here is not getting propagated for some reason? Which is pretty odd. Let's say, make sure that we have this in normalized coordinates, just to make sure, but it should be fine. So we're definitely just seeing like a constant color, which we definitely shouldn't be seeing. So, I'm confused. I'm definitely confused. I'm gonna back out all of my changes to the vertex and fragment shaders, just to make just to compare. Yeah, so that's weird. Like, now it's working correctly, and so now we can just start like working our way back to where we thought we should be there. So here we'll say that we get a second thing in, which is the texture chord. And if I run, does that still work? Still works. Then we pass the texture chord here, and we see nothing, but that's kind of expected, I think, because in our image renderer, we didn't enable this guy, so let's just enable him now. Which is getting closer. That looks like we're seeing something still. Here we need to pass invert as the GL position. Okay, and then we just have to go back to our fragment shader and stop using the normalized vert. Okay, so I don't know why. We must have done something fucky-wucky in our like shaders, and I should have checkpointed that so that we could compare. Because I don't really... This feels like exactly the same as what we just had. But it's like clearly not. Whatever. That's weird. Okay, but now let's try scaling it down. And what we should see is a scaled down version of the guy. Yeah. Alright. Well, I don't really understand what I fucked up last time, but that's okay. Let's just double check here that everything looks sane. So here we put the vertex and texture coordinates packed tightly. So maybe here we should just say, we should comment this is like vert x, vert y, text x, text y. All right. And yeah, all right. Okay, so I think that we can say render glyph to specific width height pause is done, and now we're at render string to string. Okay, so what we should expect to see is that freetype, when we render a glyph, should tell us where that glyph should be placed relative to some location. So it should tell us, like, let me think. How do I say this? It should tell us the width and height that we should render at, as well as how far to move the cursor at the next thing. So let's start by rendering this thing with the expected width and height. So here, when we create our like character mappings, we store all of the like important things. Left, top, width, and height. We store all of those. So I guess when we set up our coordinates here, the top left is what we pass in for x and y. So here we'll say the x position isginfo.x, or top, or left, sorry. Should be ginfo.top. And then the width is ginfo.width, and the height is ginfo.height. Now, the problem here is that we don't know what the coordinate systems of these two guys are. Certainly, these values are not in normalized coordinate systems like we expect. Or it's not even normalized. This is -1 to 1. Maybe we should always, maybe the API to this guy should work in normalized coordinates. That might make more sense, but we'll see. The other fun thing to do with freetype, assuming you have a sufficiently new version, is to enable SDF when rasterizing your glyphs. The night and day is and difference is better. Text is night and day difference better. What's SDF? Syrian Democratic Forces. Let's steer away from that and look at freetype. So is SDF, what does SDF stand for? Oh my god, that is so much better. Holy shit. So it does look like they're still just sampling the texture. Why would it be so much better? Signed distance field. I've heard of those. Those are like, each pixel is like a distance from the next one or something. Signed distance function. In math, the signed distance function is the orthogonal distance of a given point x to the boundary of set. What is this guy calling in? I can't remember. What is the name of this? Omega in metric space. The sign determines whether or not x is in the interior of x. Oh, okay. Sure. So these guys are going to have, like, I guess, bigger numbers towards the center, because they're saying if it's interior, it's the distance of a given point to the boundary of set. Right, so I guess all of these guys are going to be 0 from the boundary, and this guy's going to be, like, larger from the boundary. So this... Yeah. So this plane... I see. So this cone comes through this plane, and so the higher the value, the farther it is. Okay. Yeah, that makes sense. Like, visually, I get it. Why does this make better? Because the lowest values are, like, the smallest numbers are the most precise in floating point, and those are closest to the edge, so your edges are going to look really crisp, essentially. And I guess also, your render function is just if it's greater than 0. So that makes sense. It basically makes it so you can rasterize the glyph once and essentially get infinite precision while scaling the glyph. But doesn't is it because it's defined as, like, a function instead of a bitmap? Like, I would think that you would still have the same problem where each pixel in your bitmap is, like, set to a number. But maybe they're using, like... okay, so they make textures, they upload the texture, they render the glyph as an SDF. So how do they, like, convert that glyph into an image? It's better to know the pixel height you're rendering at and use that. I could see the argument that you're saying that you could lose corners. The main thing it changes is your framing share. I'm more trying to figure out, like, what is it? Like, what comes out? Oh, font rendering on Chronos. Signed distance field. Okay, that seems interesting. So what do they do? This guy has no idea. Freetype GL. I don't want to... That's a lot of links. Can we just look at, like... I just want to know, like, what the data that comes out is. We can figure it out from there. Convert vectorial outlines to 8-bit sign distance field bitmaps. Ah, okay. So it is still a bitmap, and so then I still don't understand. You wouldn't have infinite precision then, I assume, right? Wouldn't your precision still be limited by the resolution of your bitmap sign distance field? The pixels black of the SDF is negative white otherwise. Okay, so that makes a lot of sense. Oh! So I guess the interpolation is probably better? Is that why? Right, because then you get like a crisp line when you linearly interpolate between like inside and outside pixels. Right, so if I had like this curve and I had like a pixel here that was like 1 and a pixel here that was 0, the linear interpolation here is like really, really good. So even with a low resolution bitmap, you would still get harder edges. That's fucking cool. That's pretty neat. I like that. I'll keep that in mind. I'm going to ignore this recommendation for now because we're so far from like even seeing like you know what? Fuck it. Fuck it. Let's try it. I'm curious now. You've nerd sniped me. We're gonna say 56, 50. Try SDFs. And at some point, get sidetracked by SDF learning. And we'll say we did that. Good job, us. That's pretty cool. Okay. So I guess somewhere in my freetype, I have to ask it to generate an SDF. So somewhere I have like my glyph cache, and when I say get character, I load this character, and I guess somewhere I just set the type. So let's look at the freetype docs. Nope, wrong thing. Freetype RS. Can I just like SDF render mode? So somebody probably takes a render mode there. So probably on either the face, almost certainly on the face is where we're gonna set this. Render mode, nope, maybe on the library itself as a whole. So what else do I have? I have library, face. So it must be on library face, right? It has to be. It has to be. Render. Can we look up render mode? Freetype : render mode. Oh, is this just like a global thing that gets set? No, this is just the only thing. So where do we use this guy? Someone must take a render mode somewhere. Render glyph. Oh, when I render it with a mode. Ah, ha, ha, ha. Okay. So where the fuck was I? Glyph cache, render, load car, render. And when I render glyph, I convert it to a bitmap. So here I see. So glyph, this is a glyph slot, and then there's also a glyph bitmap. So here, probably just before I get the bitmap out, I should say glyph render glyph with the render mode. So this is freetype render mode SDF. And probably I then say like render as SDF is going to be my error type, which is going to have to be oh shit, what did I just do? Which is going to have to be defined somewhere. So we'll say render as SDF, and this is probably a free type error, and the string will be failed to render glyph as SDF. Oh, sick! Let's go. That's cool. Okay, so now we just have to change our shader code. So our fragment shader is just going to say greater than 0. I actually don't know if that works that way. That might not compile. I'm not really sure. Nope, definitely not. Cannot construct vec4 from a non-numeric data type. So I guess I have to say that like float value is equal to vert. We sample the texture. we sample the texture. We take its red thing, and we say it's greater than 0, then 1.0, else 0.0. I think that ternaries work here. And we can just write val here. I think. No, he doesn't like that. Too few components to construct vec4. So here I'll just repeat val, val, val. Okay. That's something. It's definitely not correct. Okay. We're close, so we have to say greater than something. How come greater than 0 didn't work here? Freetype SDF. So it should be, we saw that it should be positive if it's inside and negative if it's outside, right? Am I high? So like, why is this just like turning into a blob? Okay, let's print the value again. And because the SDF will be non-zero on outside edges as well. But wasn't greater than 0? Greater than 0 should threshold. Maybe it's less than 0? Was I? No, it does seem like the value is always greater than 0. I'm missing something. The pixel is black as the SDF is what negative white otherwise. Yeah, so what the fuck am I missing? Right, like if I don't do this where I threshold, like this is reasonable, right? Like if I look at the value, all of the stuff that's black here should stay black. So I don't understand, the thresholding must not be working the way I expect. Like greater than 0, question mark, 1.0, else 0.0. Like I can't imagine why this would be behaving differently. Like, and if I set like a small value, it does look different. And clearly I'm seeing like the shape of the letter C in there somehow. Oh! It's because I bet you it's because I'm interpreting the data as unsigned. So probably if I were to print out this glyph, I bet you I would see numbers in like negative 127 to 127 or something. How can we check that? When we get the character, one of the things in here, we could like look at this bitmap, and oh no, but then we saw a lot of black. Oh, whatever. Let's print out this guy and like take a look at what the actual data is. Print line glyph bitmap. Cargo run. I can't just render the bitmap. Bitmap buffer, probably, to get the actual data. It is really simple. That's what I'm thinking. It seems really simple. Yeah, there's zeros. 0 to... Okay, yeah, we're seeing no negative numbers. Then when we pass it in, we're interpreting them as... Where do we do this? Where do we like create the texture? We're passing them as unsigned bytes, which seems still correct. I guess we should double check. At some point we checked the glyph format. I think it's glyph bitmap pixel mode. Okay, so it's grayscale, like we expect. So if we look at the freetype docs, they should have pixel mode, which returns gray, which means that this is an 8-bit bitmap used to represent anti-alias glyph images. Each pixel stored is 1 byte. Note the number of gray levels is stored in num grays field of the bitmap structure. Okay, that's interesting. So let's say let num grays equal to glyph bitmap num hello num grays. Well, okay. The number is stored in the num grays field, generally 256. All right, well, based off what we see in the data here, we really should see the values thresholded at 0. And again, it makes sense in our fragment shader. If we don't do this thresholding, it really looks like we see a bunch of zeros. Draw white near what yields 0. That does seem like a good idea. So I guess we do like 1 minus this. Which does again, draw white near what's near 0. So we should do like sorry, let's think. So if it's near 0, we can just draw things that are less than like 0.1. Oops. Then do the same thing, 1.0 or 0.0. Oh, so it's, I guess maybe all of the stuff outside is close to 0, and the mapping from like 0 bitmap to 0 float maybe is not very good. Because what we actually did see in our like output sign distance field is we saw a bunch of zeros, and that's not what the Wikipedia article said. The Wikipedia article said it would be negative outside, 0 inside. And so we're actually seeing that all border is 0 values. So when we say greater than 0, it might be, there might be some like floating point imprecision there. So we could just pick a threshold value that's like red is greater than 0.1. Like maybe like even like 0.001 would be like good enough. Oops. And we forgot to do the 1.0, 0.0 again. And we just have to pick a value. It's good. In your fragment shader, you can also use F width to get that delta and mix that with the colors with smooth step. I just feel like I'm missing something obvious for why. I feel like I'm not understanding something. I wonder if it's like threshold at 0.5. Right? If it's threshold at 0.5, that would make sense. Given that... how do I say this? Given that the values that we're seeing are between 0 and 255, right? Like, this is fucked. So I wouldn't be surprised if the values are not negative and positive. And so we should check what freetype says it's going to output for those SDFs. So SDF freetype and data format. So he renders it as SDF. And yeah. If glyph shape is less than 0.5, discard. Okay, so it looks like 0.5 is the threshold value, not 0, which makes sense because we're using unsigned integers. Sure, fuck it. Cool. And you are right, that just looks like way fucking better. That's pretty crisp. Which is pretty sick. Pretty sick. Let's try a different letter. Okay, we're also upside down. And maybe backwards. Because that's supposed to be an A. Probably just upside down. So here we'll just flip Y coordinates. In the texture coordinate system. Australian A. Yeah, that's pretty sick. We probably still need to increase resolution. I just copy-pasted values initially from like some random thing that I got from some example, but yeah, that does just look really crisp. Pretty cool, pretty cool. Okay. Okay. Yeah, it's pretty sick. Okay, so let's go back to rendering strings. Back to rendering strings. You were throwing away the anti-aliasing. You want to have values that are only 1 or 0. That's why I did discard instead of what you were doing. Oh, that makes sense too. Good call. Good call. Yeah, so here I would just do if val is less than 0.5, add rip. Otherwise, we do val. Okay, cargo run. And that's pretty cool. And then probably somewhere we need to set our interpolation as well, actually. So when we reload our texture, let's just make sure that we're linearly interpolating. Which would be in our glyph cache. Are we doing linear interpolation? And we are. Okay. All right. Good enough for me. Good enough for me. Okay. Function returns the distance of pixel edge. You can smooth it as you like. Yeah, that makes sense. Okay, whatever. I'll leave it like that for now. I'm happy there. And let's update this time. Okay, back to rendering strings. For real this time. So for each character, we're gonna have to do some sort of mapping from like freetype space to texture space, or to like OpenGL system space. And really, like, I don't like these like -1s to 1.0. I think everything should be normalized coordinates, and that'll make everything easier for me. So I'm actually going to say that that xgl is equal to x times 2.0 minus 1.0, and ygl will be this, and that'll just make it easier. And I guess I should probably name that. So we'll say function norm to gl chord. So this will be an F32 to an F32, and we'll just do chord times 2.0 minus 1.0. So xgl is norm to gl chord. Or maybe we could even work in normalized coordinates in here and adjust them in our vertex shader. That's probably the nicest. Let's do that. So here we'll just say that our invert is plus 2 or times 2.0 minus 1.0. All right, which means that now we should be able to say that if our width, if we start at 0, 0 and have width of 1, 1, we should see the full screen, which is what we're seeing. Stream is lagging. I am seeing some frame drops. Fuck. How bad is it? Is it like unwatchable? Not a complete halt. Yeah, I'm seeing like bitrate chunk down to 3,000 kilobits per second instead of 6. Fuck. Let's maybe give it a sec and see if he recovers. Has it been like this the whole time? Or only recently? Every 2 seconds there's a big drop. Oh, yeah, it's annoying. Annoying. Yeah, I'm seeing network tank. Look. 1 sec. Are we back? Since a minute. Okay, so maybe we just have to wait it out. Oh, it's so fucking annoying. Okay. I guess I'll keep going for now. Unfortunately, I don't know if I can like adjust my encoding settings on the fly. Let's see if I can do that. Settings. Output streaming. Can I just like lower my expected quality and just kind of hope for the best? Could you imagine if plumbing was unreliable as the internet? Fuck, that's annoying. Okay. I'm gonna grab a glass of water and see if it fixes itself while I'm gone. Fuck, that's bad. Well, just give me a second. Okay. It looks like it's green again for a little bit. I'll keep an eye on it, and we'll just keep moving and hope for the best. Hope for the best. Sorry about that, guys. Okay. So where were we at? Yeah, it looks like it's better. Okay, so we were checking if rendering in normalized coordinates works fine, which it looks like it is. And, well, I guess we have to check. In our fragment, instead of discarding, we should just set val to 0. There we go. And if we set our width and height to 0.5, cool, we do see it in the corner. Nice. Nice, nice, nice. Okay, so let's try to convert these free type coordinates into normalized coordinates and use those as our offset. So, can we look at the free type I guess we can look at the OpenGL example and they'll give us a clue instead of trying to parse through some docs. So what these guys said is that the advance is adjusted by its 64ths of a pixel, and the x position is the x and y, and the width are just x and y. Okay, yeah. So the times some multiplier. So we'll say const scale is equal to 1.0 for now, and we'll adjust it as we need to. Right? And then we'll just say let x is equal to g-info dot top or left times scale. Y is the top times the scale. Is that what they did here? That makes sense. I think multiplying both of those by scale makes sense. They do have some sort of like bearing thing in there, but we'll ignore that for now. Until we figure out what the fuck's going on here. We say width is width as f32 times scale, and height is g-info.height as f32 times scale. And then we can just punch those guys in here. So we say x, y, width, height. This guy needs to be a uppercase scale. Cool. And let's run it. And we see nothing. So it's either way too small or way too big. So we should actually just print these out. X, y, width, height. And those are, x is -7. That's weird. So these guys can go out of their bounds, which is kind of fucking annoying, but that's okay. So our width is 31 and 32, so we need to multiply our scale by like 1, maybe like over 32 for now. Let's just see if that gives us something a little more sane. So we're getting like a height of 1 and our width of near 1. Let's just set our x and y to 0 for now. Okay, so that's reasonable. And then our width and height are supposed to be relative. I think they said the advance is 64ths of a pixel, which is weird, but everything else looks like isn't, unless they did some conversion later. So can we look at maybe the freetype docs and look at the bitmap class? And the width is the number of pixels, rows is the number of rows. Okay. Pitch is the number of bytes taken up by one bitmap row. And then what happens if I do like a big A? Does my letter get bigger? I'm also kind of concerned about like the size, but it does look, that looks pretty good. Okay. So now if we wanted to render a string, we could say like for character in like test, that seems reasonable. We're going to, oh, this is, yeah, that's right. So we're going to render each character at its own position. So we're going to say let cursor position is equal to, like, we'll put it in a little bit because we've seen some negative values. We're going to say like cursor x is going to be 0.1, we'll call it. And we'll just set cursor y to like 0.2 or something hard-coded. Let's not really worry about the, how do I call this? The like y offsets. I'm going to assume that there aren't any for now, but I could be wrong. So we're going to use capital T, EST, and then we're going to say, we're going to iterate over characters here. And for each of these, we're going to have to get the character. And we're going to advance is equal to, or we'll say cursor x plus equals the advance x divided by 64.0. Okay, so 64.0 F32. And we mutate this guy. And then here we just say that the x position is cursor x plus. Cursor x plus. And then here we say x. Here we're going to put our scale to be like 1 over 128 or something, just to see. Okay, so we get our t there. That's good. It's kind of weird that we're not getting any of the other guys. Right, like, shouldn't we be seeing TEST here? Our X values are maybe getting very large here. So I wonder if these guys are also in, like, stupid units. I forgot to time scale here. That's why. Okay, so that's something, right? Clearly not perfect, but something. Let's go back to our fragment shader and discard these guys instead of setting to 0. So we'll say discard. Okay, cool. Now, our Y offsets are clearly fucked up. I'm just gonna go out on a whim and say that we might need, it might be from the other side. So if I put that to be negative, that doesn't work out the way I expected. 1.0 minus maybe. Okay, still fucked. Let's try to like reason about how these are wrong. So I think if I remember correctly, I saw somewhere the free type coordinates are maybe from the bottom. So where am I pulling these these values from? I actually don't remember. So let's start there. So we'll look at the glyph cache, and we're getting these from bitmap left and bitmap top. So let's look at what these guys are. The bitmap's top bearing expressed in integer pixels. Remember that this is the distance from the baseline to the topmost glyph scan line. I see. So if I am at 0. Like let's render these all at 0.5 for now and see what that looks like. Ah, okay. Okay, so that's looking maybe okay. And so I guess the problem is that we're rendering how do I test this? I think that we might be rendering like I have to check what the OpenGL coordinate space is. That might be relevant here. So if we go to let's say we start at 0.0 and we render at y 0.0. That's bottom left. And if we go to 1.0, 1.0, that should be top right. Oh, but we can't do 1.0 because it's too high. So 0.8 maybe we'll say. And of course, this is also out of bounds. So 0.8, 0.8 should be near the top right. Okay, so OpenGL coordinates are 0, 0 is bottom left. And so they're saying that the bitmap top is the distance to the top corner. But we're drawing from the bottom corner, so we actually don't care. So we can just discard this y value, and we can set y to like just the baseline, if I understand correctly. So we'll just say for now that y is 0.5, and otherwise I think it's okay. Oops, let's set our x position to maybe like 0.25 or something. That seems reasonable to me. I would like to increase the resolution of these guys. So I'd also like to understand in my glyph cache, one of the things we do is we set the character size, and I don't know what that does. So on our font face, we can set character size, which is the width and the resolution. So I don't understand what the difference between like size and resolution would be. I don't understand. So let's look that up. So freetype set car size. Setting character size in freetype. 1/64th of points. So they're saying, this guy's saying 0 probably, shouldn't that depend on the actual glyph? Yeah, okay, I agree. The functions are set the size, not of an individual character, but of the EM square for the font, which is a notational square that may be as tall as the tallest character, but may not in fact be the same height as any character. It simply defines a reference dimension. The main meaning of setting a size point of 12 is to create characters that usually fit onto baselines 12 point apart without clashing. Okay, so the height and width are separately settable so that you can create expanded or condensed fonts, sure, but I don't really want to do that. So normally you leave the width at 0. Okay, that seems reasonable. Here we did the other way where we set the width to something and the height to 0, but sure, it doesn't really matter. Like one of them will be automatically resolved from the other. Meaning that the width of the EM is to be the same as the height, and the characters are to be created in their standard proportions and not stretched or shrunk. There is no reason to set the car size rather than set the pixel sizes other than the fact that car size gives finer control. Set pixel sizes does not allow fractional pixels which are meaningful when created anti-alias glyphs. The end result is always calculated as being both the EM size. Okay, sure, whatever. So can I just say, like maybe I just here, because I don't really care that much, can I just say set pixel sizes and just set these to like be like 64. Interesting. And here my anti-aliasing is actually clearly broken. So I'm going to go back to my fragment shader, and we'll just I don't think that I should be punching in the value here. I think the thresholding was pretty reasonable. So we'll say if we'll just say 1.0 here everywhere. And we do get this like kind of like chunky behavior, but I don't care about that for now. Who would have guessed that renting some characters on the screen would be this hard? I've actually heard that fonts are a massive pain in the ass, so that's actually not that surprising to me. Okay. So we'll just reduce the scale again here. And that's pretty cool. I'm going to have to figure out how to smooth the edges eventually, but for now, that's pretty sick. Let's see. I want to see like a range of characters. So maybe what we'll do is I'll probably have to split these by line, or I can just make my screen bigger. Let's do that. So here we'll do a like 760 by 760 or something, and probably gonna run that. And I just want to like, okay, and then let's shrink these guys a little bit more. So we'll shrink them by, you know, 512. Is that enough? I just want to see like what a range of characters look like. Am I rendering a font that I like? That's okay. So there's some clear mistakes in here. The fact that my Q's and my P's are raised means that my the top, with the fact I'm just rendering everything from the bottom, and that was like clearly wrong, right? Because they have the top, so we just have to offset instead of by from the top, we have to offset by the bottom, because in OpenGL we're rendering bottom up. And so here we're just gonna say y is equal to our baseline 0.5 plus top minus width, top minus height, I guess. G info dot top minus G info dot height. So if the top is smaller than the height, we will move down. If the top is the same as the height, we won't move at all. And if the top is greater than the height, then we will move up, which seems reasonable. We need to multiply this by scale. And let's see if that lines up. Okay, there. Now our Q and our P look like they're in a much more reasonable position, and the J as well, which is pretty sick. I would like to render more characters. So first of all, why am I starting 25% of the way in the screen? Let's start like, you know, maybe close to the edge so we can see more characters. Yeah, sure. That seems pretty reasonable. Eventually, we'll have to fix anti-aliasing, but I'm pretty happy with that for now. Okay, so now, what was like the original thing that I was actually trying to do? I was trying to make like a countdown of some form. So I guess what we're going to do is we're going to define, I guess let's pull out a function to render a string generically. So maybe our image renderer, for now, we'll just put this guy on here. He doesn't necessarily belong here, but we'll throw him here for now. Render string. No, he doesn't belong here. And he can't belong here. We'll just make a function here. We'll say function render string. Luckily, SDF gives you anti-aliasing for free, essentially. So that's what I'm kind of missing, is it feels like if I don't threshold, I get like weird looking characters. Let's go back to that, actually. You've piqued my interest. So here, if I put in the value of, oh, maybe I put that in alpha. No, that doesn't make sense. So if I put in val here, I guess, yeah, if I put in like the value of the character from the SDF, and maybe I, let's see, let's make them kind of bigger so that we can see them better. So we'll go to like 512. We'll go even bigger. Cargo run. See, like, what I don't like is that I'm seeing like the shape of the SDF in here, right? Like I'm seeing like a thick line in the middle and a thin line around the outside. So I feel like I'm not understanding something correctly. I guess I should make like a linear interpolation, or maybe not linear, some sort of interpolation that basically says like we max out at some value above 0.5. So you would do something like val times is equal to val minus 0.5 times something. If we were going to do linear, maybe linear is not the right thing to do. So we could do like times 5 or something, which would get us to like the maximum value extremely quickly. So let's see what that looks like. Oops. Nope. We want I guess plus something that gets me to 0 quickly. Or maybe just 5 was too short. And I guess maybe we want 1.0, 1.0, 1.0 alpha val. So the things on the edge will have low alpha, and then maybe we can decrease this a little bit. Maybe. I don't know. I'm just kind of like guessing all around. Try using something like float R is F width red. And then something like smooth step 0.5 minus R. What's F width red do? F width, the sum of absolute value of derivatives in x and y. Oh, so this checks the like range of all red values in some way. And then I smooth step it. Which is like an S curve. I see. I'm gonna come back to this later because I wanna do some reading off screen to get a feel for what's normal. So for now we're just gonna go back to everything being it just being shittily anti-alias, but that's fine for now. Fine for now. I wanted to get back onto animating stuff. So let's try let's say I wanted to like animate the typing of text with some form of delta. You would want to like for each frame, you would want to check the timestamp. Oops, I typed in the wrong time here. You would want like some form of timestamp that we do per frame. We would want to wait a certain amount of time per character. And then once we hit that time, we like enter the next one. So probably we're gonna have like some sort of like struct typing animation. And he's gonna have inside him, he's gonna keep track of like what he wants to type. So like desire or like S, we'll just call him for now for the string. And maybe we'll take the timestamp as well. Like starting time is going to be a monotonic time instance, I guess. So we'll look at use stood time instant. And then all we have to do is like figure out the length and maybe like how long we want to type for, right? We're gonna say like total time is going to be some form of like duration, I guess. Okay, so then we're gonna have like an implementation for this guy, and we're gonna say, well, I'm gonna render some. I want to render this string every frame, and I guess it's a little nicer to take in the time as like an input to this function instead of calculating inside, because theoretically, not that I'm going to, but you could unit test it a little better that way. So I'm gonna take in now as an instant. And let's say that we just wanted to like linearly interpolate the time, right? So like each character gets like a specific amount of time. I think usually for animations, it's better to do some sort of like curved animation, like where you accelerate and decelerate, because it like just our brains like that a little better. But for now, let's just try that. And so we're gonna say, we're gonna run this loop, but we're gonna limit what we type on this specific frame by how long it's been since we started relative to the total time. So we can say like let like duration since start is equal to now minus self dot start time. Then we're going to say for character in s.cars, but we're going to limit this, but we're going to like only take the first n characters. And I guess we're going to take like, it's going to be some function of the length of the string and the duration. So we're going to say duration since start over self.total time. I assume that this yields a float. But I actually don't know if this is like valid. So let's see. Expected U32 found duration. Okay. So how do I like find the fraction of two durations? I guess I can say as 32 floating point seconds for now, which won't give the most precise results, but that's okay. So this is like the percentage of our time that we're into, and then we'll just multiply that by the length of the string. So we'll say let num cars to render is equal to this, and then we'll take num cars to render, and here we need to take in a few things like the font cache is a glyph cache, which I guess is an indication that we are using the wrong name here. Are there no casts in Rust? There are, but like no implicit casts, which I prefer, to be honest. I always turn on the C++ compiler arguments that disable implicit casting because they fuck me up all the time. This will return a result of nothing if it succeeded, and we'll just say main error for now. If it fails, just to like get all these casting right. Scale needs to be pulled in here, and cursor X needs to be pulled in here. And otherwise, we only need the GL as well. So GL is a GL context, or glow context, I should say. And at the very end, we just write, okay. Okay, it works. We also need the image renderer. And I don't know if it needs to be mutable or not, so. And then we'll also make this unsafe. Okay. This guy needs to be cast down to usize after to be truncated from an F32. And we need to throw some mutes around. Isn't it boring and frustrating when switching between insert and normal mode? Like, in Vim? Boring? I think, like, if I'm understanding your question correctly, the whole, like, benefit of using Vim is normal mode. Like, if you don't want to be in normal mode most of the time, you shouldn't be using Vim in the first place. It's like, you know, if I'm like in normal mode and I want to like delete everything in these brackets in the render function, I can just do that. If I want to like jump to the spot where I see cursor, like that's easy to do. If I want to like go to the end of this line and find the corresponding bracket, like I press a button. And so I just like have all these buttons like in my head, like a language almost. And if I didn't want to be in normal mode, I wouldn't be using Vim at all. Yeah. Okay. Sorry, that's an aside. We don't want to get looped into editor wars. In reality, it doesn't matter. Use whatever feels good to you, you know? Okay. So now we're going to construct our typing animation up here. And we'll say, like, let animation is our typing animation. Sorry if you interrupted. Oh, no sweat. No sweat. If I didn't want to answer it, I would have just ignored it. So we'll make a new animation, and we'll take in the string that we want to construct. And we're going to return a typing animation. And here he's going to take in s. He's going to take in the duration as well. I guess we'll just take in, you know what? We don't need to make a new function, so we're just going to pass in like literally every single value here. So we'll just make our typing animation here with a string of test string. Our duration is going to be like duration from sex, and let's sex f32, let's say. And maybe we'll say that we're going to animate over 5 seconds. And now, or start time is going to be instant now. And then, on every frame, no field duration, what does he say? Total time is what we called it. And then for every frame, instead of doing this, we're just going to say animation.render. And we're going to say now is instant. Now the font cache gets passed in, the GL context gets passed in, and the image render gets passed in. We have a bunch of ampersands to type because Rust, you know, the way of the world. And here we, I guess we just return an error if there is. All right, that's kind of cool. Test string to string. What would it be if you don't put the to string on the string? Yeah, so when you type like, where am I? If you type like test, this is of type and static stir, where lowercase stir is the like reference type, and if I say like test to string, that goes into a string, which means that string is like take the thing in static memory, malloc a new buffer like on the heap, and copy paste it into there essentially. So string is like the heap allocated owned type, so you could like modify it if you want, and like stir is the reference type that you cannot. Well, I shouldn't say that you can't modify, because you could have mutable references to strings, but generally, yeah, you can think of string as heap allocated, stir as somewhere that you don't own the lifetime of. Okay, I want to reduce the font size a little bit again. So maybe 512. And I want to reduce the time that this is going to be rendering for. So 5 seconds is too long for that. So let's say maybe like 2 seconds. And it is true that my brain doesn't like that disgusting linear easing function. So I think I saw somewhere there's like a visualizer somewhere for these easing functions. And so probably like this is what we want. Probably, that's probably fine. Which is something like this. So here we're just gonna say, let, like, what is this gonna be? This is gonna be like, amount of string to render is equal to, a cosine of pi, which I don't know if we have here. Does pi exist in the Rust standard library? Pi. Not pi, my fucking pi. F32 const pi. Okay, so let pi. Can I say like use std f32 const pi? Okay, so then we can use pi here times the duration. So we can say this duration thing is like let linear or time percentage. Percentage is the wrong word because percent is per 100. I want per 1. I don't know. Amount of time test. I don't know. I'll have to find a better word for this normal. later. And so then we're going to multiply this by amount of time passed. Factor. I like that. Time factor. This guy needs to be minus 1.0 divided by 2.0. And we'll call this string factor. We say string factor times the length as an F32. Okay, so let's see if that like looks any less shit. That felt better. I want to have to fix whatever's telling it to crash all the time. So we're calling get character error renders SDF invalid argument. So am I like passing in something fucking stupid? TEST. Oh, I'm putting in like a new line or something. Oh, because it's a space. So spaces just aren't valid glyphs, which is kind of interesting. So how am I supposed to handle a space in freetype? I'm assuming that I'm supposed to just advance by some amount, but how do I know what that amount is? Oh, I guess it's just I don't render it. Maybe it's the null byte. Spaces are definitely valid. I mean, I'm definitely seeing that we don't get to the point where I type string, right? If I say test string, what the fuck? Oh, that's pretty funny because my I'm getting over 1.0. That's pretty funny. So it's going in and out. But you can see that like if I put that space in there, he doesn't like that. So I wonder if I'm using some like stupid fucking UTF-8 character instead of the expected ASCII character. So maybe here when we do the character, can I say like ASCII to ASCII? They're only uppercase. Rust car to ASCII. I guess it's valid. How do I say this? I think UTF-8 fully overlaps with ASCII if it's within the range. But also, like, what is the API? Like, load car is taking in C as a U size, so clearly, like, something here is fucked. So what does he expect? Free type here. He has a load car function who calls ft load car. And let's just see what he expects, because I was just like randomly casting, which is like clearly not expected. Okay, so it's possible that I have to set the encoding. Character mapping. This section holds functions and structures that are related to mapping character input codes to glyph indices. Note that for many scripts, a simplistic approach used by freetype of mapping a single character to a single glyph is not valid or possible. A higher level library like Harfuzzer ICU should be used for handling text strings. Fuck! Okay, we'll ignore that warning for a second. So it looks like somewhere we might want to say that it's Unicode, and we should call get car index with Unicode, probably. Return the glyph index of a given character code. So how do I... But like load car, I think took the character code, if I remember correctly. ft load car. So I pass in the character code. And the glyph's character code according to the current car map used in the face. So I guess maybe I have to set the car map to be UTF-8 so that it knows. ft car map. A handle to a character map. A character map is used to translate character codes in a given glyph encoding into glyph indexes for its parent space. Blah, blah, blah. So how do I get one of these. Do they have, maybe these guys have, in the Rust bindings, set car map, set car map, base. That's weird. Like, shouldn't these bindings have character mappings? Freetype RS character mappings. What's this guy doing? This is not what I want. The learn OpenGL page, that guy said something about it. Let's just see, are these guys doing anything to set the character map? So he says, init freetype. He has a new face, set pixel sizes, then he just loads the character. Freetype space invalid character. Golang got this right. Anything in the program is UTF-8. You set up encodings for I/O. Rust might be doing something similar. But yeah, you're right. I agree with you. Can we just like render as SDF invalid argument for a space? Nope, that's given me nothing. Okay. So render glyph calls ft render glyph. And I guess load car is succeeding. And so maybe, right, because here we load the character, then we get the glyph, then we try to render the glyph. So it's possible that we're just not allowed to render glyphs for something that has nothing in it. Like a space might have glyph slot information, but not a glyph itself. That seems possible. ft render glyph. Hello? Is that not the right thing? This is ft render glyph. Why? So I googled that function, and then I click on the first link, and that string is just not in there at all? What the fuck? ft render... Like... DuckDuckGo, why are you giving me this page? ft render glyph. Here we go. So convert a given glyph to a bitmap. It does blah blah by inspecting the glyph image format, finding the relevant renderer, and invoking it. Return. Okay, no. When it outputs a bitmap of a glyph, it really outputs an alpha coverage map. If a pixel is completely covered in by a filled-in outline, the bitmap contains an FF of that pixel. Blah blah blah. Where are like the failure modes? Render modes, blah, blah, blah. SDF is a special render mode that uses up to 256 distance values, including the signed distance from the grid position. Note, the selected render mode only affects vector glyphs of a font. Embedded bitmaps often have a different pixel mode, like mono or convert. Okay. So it's possible that if I render, like, SDF renders might just not always work, right? So I bet you if I go back to this, it would be interesting to see. So that works, which is kind of interesting. So it looks like it's something related to yeah, it looks like it's something related to SDF renderer and certain characters. So I guess we can just say, we can just try this, right? We can just say, if this fails, that's like totally okay. It doesn't actually matter. What we should do is we probably need to we need to keep track of what mode the bitmap is in, if it's in SDF mode or normal. And depending on that, you could try setting the render mode on render to normal and set the load flags to SDF? Is that something that's possible? What's in the, like, load flags? I don't see anything SDF related in here. I think for now, I'll just say, if we could say, like, if the SDF render failed, then we'll just try rendering it normally. And then we should adjust our fragment shader in that case. Or maybe our fragment shader that's thresholding on 0.5 might just keep working okay. Right, that might be totally fine. So, yeah, I think we'll just say, for now, if let e is equal to this, let's just log it for now and move on with our lives. So we'll just say, print line failed to render glyph with SDF for C, and we'll just get this log sometimes, and I'll deal with it in the future. Oh, you saying that there's FT load targets that have render flags? I wonder why render, like, I have load render, but then I don't know if I could set the render flag. That might be like a Rust bindings issue, or it might be that maybe I'm allowed to do that. So you're saying that, like, I could do render FT, like, load target. Maybe there's, like, SDF. Like, is there render mode SDF? Yeah, I don't know. I'll figure it out later at some point, maybe. And for now, we'll just leave it this way, because I wanna wrap up this, like, animation thing. I just want to, like, wrap this up real quick before we get to the end. So the last thing I want to do here is I just want to clamp the easing function. So here we just need to make sure that the time factor is clamped to 1.0. So we'll just clamp this between 0 and 1. Nice. I feel like this easing fell off too far at the end, so easing function examples. And let's just, so we used ease in out sign. I kind of want something that slows down less. Or I guess I could just reduce the duration. Let's see if that feels better. This is very scientific, very scientific. So if we say do it in 1 second, does that still feel fucked up? No. 1.5 seconds? Maybe I don't want it to slow down. I think that's probably just what I want. I want something more like this that starts slow and ends fast. So maybe ease in sine or ease in cubic seems reasonable. Ease in cubic is easy to type, so I'm going to type that. So we're going to say time factor POW 3. And maybe that'll feel better. A little too tail heavy. So maybe something like ease in sine actually feels better. So this is just this guy. Cool. So 1.0 minus F32 cos time factor times pi over 2.0. Yeah, that feels okay. Cool. That's pretty fun and easy. Okay. I doubt I'll do another stream on this. I think probably I'll just experiment with, like, the look I want and stuff off stream. I don't think there's, like, really much value in doing the rest, right? We've kind of covered the interesting parts of string rendering and, like, animation in OpenGL. A blinking cursor would be cool. Yeah, that is what I was thinking, was at the end I did want to have a blinking cursor. But I don't think that's not too difficult, right? Like, we already have the concepts covered for how to do that, right? We just have our fragment shader, we're already just drawing a square, and all we would have to do to draw a blinking cursor is like, instead of drawing from a texture, you just type like 1.0 here, right? So it's pretty much the same thing. And so, yeah, I probably will look at that eventually. So I think, yeah, I think I'm pretty happy with where we ended this. That feels pretty good. So thanks for watching. If you liked what you saw, I stream on Twitch most days at around like 1 or 2 o'clock Pacific time, with for like maybe like 1 or 2 hours depending on the day and like what we're working on. The major project that we're normally working on is operating system development. So if you're here seeing OpenGL dev, this is kind of like a one-off, and we'll probably get back onto like process loading and our custom OS soonish. If you're watching on YouTube and you want to come in, say hi, chat, whatever, there should be a Twitch link in the YouTube description. Yeah, in Twitch there's a link to like my GitHub and a Discord if you guys want to join for whatever reason. Yeah. On that, I don't think I'll stream tomorrow, but I'll be back on, what day is it today? Today's Monday, so I'll be back on Wednesday. Yeah, thanks for watching. Catch you on the next one. Bye.